The topic of the video is generators of infinitesimal rotations. Angular momentum of a particle of mass m located at the position vector r and moving with velocity v is defined as L equals to r cross p, where p is momentum, which is mv. In components form, if r bar and then p bar are defined like the first two equations, we can actually obtain expressions for the components of L through a determinant shown here. So we can write down the component Lz as xpy minus ypx, but the operators form of py and px are in terms of partial derivatives. So we can even write down Lz as minus ih cut into x dou by dou y minus y dou by dou x. And in spherical polar coordinates, this Lz will look like minus ih cut into dou by dou phi. Next in the discussion is infinitesimal rotations unitary operator. If psi phi is a state function of the system at an angle phi, and it can be transformed to a state function at psi phi plus d phi by the action of the infinitesimal rotation operator r phi, as shown here in the box. Expression for this operator r. Taylor's expansion for the function psi of phi around a point A is given by this summation here. And if you neglect the second and higher order terms, it will look like this. And if the point A is very near to phi, then we can replace that with phi plus d phi in the above equation. So we get this equation. And then if you pull out psi phi plus d phi outside, we get the remaining thing in the square bracket in front. And as Lz operator was minus ih cut into dou by dou phi, we can write down it by noting it dou by dou phi is equals to I by h cut into Lz. So the above equation will become psi phi is equals to the thing in a square bracket into psi phi plus d phi. And if we multiply that equation with the inverse of the operator which is present in the square brackets on both sides, we get expression for psi phi plus d phi as shown here. Since this operator should be, since the operator present in the square bracket should be unitary, then we can replace its inverse by its dagger. Since the dagger for small I is minus I, we will get the thing in the square bracket like this. So we can say that the rotational operator r sub r d phi is equals to I plus small I into d phi or h cut into Lz. Generators of rotations. Lz is called generator of rotation around z axis, about the z axis. And similarly, Lx will be the generator of rotations about the x-axis, and then Ly will be the generator of rotations about the y-axis. That's it in this video, and thanks for watching.